morning, everyone. My voice is audible. Good morning, everyone. I'm asking my voice is audible. If yes, then please reply in the chat box. क्यों नहीं? Reply. हाँ, सर से पूछो. तीनों ट्राई कर लो, कोई भी कंपेयर कर लो। वीडियो फ्रंट वीडियो उससे डिफरेंट है। वही कर चुका मैं, ये सब कर चुका हूँ पहले, तो ठीक है। 8, आपको नहीं 7 लोग। क्या? हम्म। अच्छा, एडमिट भी कराना है इसमें? एडमिट भी एडमिट भी कराना है? Good morning, everyone. Now my voice is audible and my screen is okay now. Okay. Okay. Good morning, everyone. My name is Pallav Arswadhan Rathor. I, on behalf of Delsoft Technologies, welcome you all for our workshop program on power system design and analysis using DIgSILENT Power Factory software. Application engineer, power system division at Delsoft Technologies, and responsible for promotion of DIgSILENT Power Factory software in India. Delsoft, established in 2004, is a research-based company engaged in promoting path-breaking software solutions primarily for the education sector, thereby helping the students to enhance their infrastructure and provide best possible software solution. We are sole authorized distributor of DIgSILENT Power Factory for research and education software in India. Today's agenda would be like, firstly, I will be showing you few PowerPoint slides. This will take few minutes. After that, in which I will be describing about the available Power Factory features and details. Secondly, I will be showcasing a live demo on DIgSILENT Power Factory. We will keep all your mics on muted mode just to avoid sound disturbance. You can during the session or anytime or at the end of the session, you can write your questions in the chat box given in the screen below. After the end of the session, we will try to answer all your questions one by one. So I once again welcome you all. for power system design and analysis using DIgSILENT Power Factory software. Okay, so here we go. DIgSILENT stands for Digital Center for Electrical Networks. DIgSILENT was the first power system analysis software. It has set trends in power system modeling, analysis, and simulation for more than 25 years. DIgSILENT Power Factory is leading power system analysis software for applications in generation, transmission, distribution, and industrial systems. For Factory 17, DIgSILENT presents a further step towards seamless integration of functionality and data management with a multi-user environment. So, one question may arise that why DIgSILENT? So, DIgSILENT comes with an integrated graphical one-line interface. It consists of one-line diagram including drawing functions, editing capabilities, and various static and dynamic calculation features. Power Factory offers the most economical solution as data handling, modeling capabilities, and overall a functionality replace of other software systems, thereby minimizing project execution cost and the training requirement. The all-in-one Power Factory solution promotes highly optimized workflow. Power Factory is easy to use and caters for all kind of standard power system analysis needs, including high-end application in new technologies such as wind power and distributed generation, and handling of very large power systems. What's new in the version? Right now, the Power Factory has the newest version, that is Power Factory 18 Service Pack 2. In each year, they just update their version with a new one. Likewise, in the 17, there was Power Factory 17, and then after that, there were 7 base packages, 7 service packs. So now the current version is Power Factory 18 Service Pack 1. So what's new? Power Factory 18 released a portfolio of new capabilities and features for improved result. Visualization and graphical representation is added. The new version comes with completely redesigned look, making the handling easier with accurate workflow. New electrical models and extension added to the existing modeling suite. Moreover, it integrates with a variety of new models and will provide an improved calculation performance. Its rich analysis and modeling capabilities perfectly suited for network planning and operation studies, from small microgrids over distribution network with distribution generation to large transmission system, new HVDC technologies and renewable generation into account. Power transmission. Nowadays, transmission grid is undergoing a major change to store increasing amount of non-dispatchable resource while maintaining system efficiency and cost. Power Factory offers complete suite of functions for studying large interconnected power system and addressing these emerging needs. Its universal algorithm can be applied to any AC or DC network topology, supports the simulation of new technologies such as converter-based power generation, FACTS, voltage source converters, VSCs, and a lot more. Power Factory is also perfectly suited to transmission system planning. It integrates a comprehensive set of tools to support automatic and parallel grid safety analysis and outage planning. Power distribution. In power distribution, different phasing technologies such as single wire earth return, two-phase, biphase, or cyclical three-phase system have created a need for multi-phase distribution power system modeling. For this, Power Factory provides comprehensive modeling features for studying all kinds of electrical network with different phasing technologies such as meshed or radial topologies and the railway supply systems to reduce network unbalance and improve quality of supply, optimize distribution network. Power Factory offers a large variety of functions such as multi-phase load flow analysis, short circuit analysis, multiple fault analysis, harmonic analysis, quasi-dynamic simulations, and a lot more. Other standard features include modeling virtual power plants, voltage drop analysis, daily load generation profiles, and easy-to-use protection coordination. Industrial systems. Industrial power systems supplying power to different industries with high power quality and high precision to ensure continuity and production and a safety. So for this, Power Factory offers vast array of functionality perfectly suited to the industrial user needs. In addition, Power Factory offers calculation accuracy, appropriate standards, clearly presented results, and the comprehensive and user-friendly interface. Power Factory offers with high precision load flow algorithm, flexible short circuit calculation features, four wire modeling, protection system modeling, harmonic analysis, and the filter design options. Power generation. Highly specialized expertise is available in many fields of electrical engineering, applicable to liberalized power markets and to the latest development in power generation technologies. Reliability and efficiency are the mandatory properties of a power plant as it represents the core of any power system. Power Factory offers tools to analyze all aspects of their electrical components. The various capabilities of the Power Factory are in the power generation, which includes various model of generators, AVRs, governors, and the power system stabilizers are given as a model in the Power Factory. Voltage dependent PQ curves, various other norms related to short circuit analysis can be performed like VD. I will tell you regarding those later. Now the renewables, we can also perform the same things like steady state load flow, short circuit calculation, balance and balance stability of EMT analysis. We can also include some of the with control stunts and statcoms. These all things can be done for the renewables. Now, right now I have the slide of Power Factory 17, and in the 18.1 there are some of the advancements. So Power Factory 17 base package includes load flow analysis, short circuit analysis, network model manager, network diagram and graphic features, power current models, converter interfaces, load flow sensitivities, overhead line and cable parameter calculation, resultant reporting, asynchronous machine parameter, and some of the advanced feature which are very advanced in which we can use for the research purposes. These include protection functions, contingency analysis, cable analysis, transmission network tools, distribution network tools, power quality and harmonic analysis, arc flash analysis, arc flash analysis, reliability analysis functions, optimal power flow, stability analysis functions, RMS, that is dynamic, electromagnetic transients, small signal stability eigenvalues, state estimation, outage planning, motor starting functions, scripting, and automation, and a lot more. Okay. Now, before going to the other part of the slides, let's open the Power Factory and see the overall layout of the software. Here, see, right now I'm using Power Factory AZ Service Pack 1. Power Factory comes with two variants. One is the education version, and another one is the research version. All those features that I shown in the slides, that is the base package and the advanced package, includes in both of the version. Only limitation is the number of the bus bars. Means the education version there is some limitation of the bus bars, only some limit. In that limit you have to design your network, and in the research version there is no limitation of the bus bar. You can design for any number of bus bars. There's only this is only main difference, and the rest all those functions analysis parts, the base package and the advanced package that shown you in the slides are in same both. Whenever Power Factory opens, it's first asks about the workspace or the backup. So for now, just close this. So this is the when the Power Factory. I will also tell you how to install the Power Factory demo version. And demo version can be used for 30 days, 28 days, and you can analyze whatever is the capability of the software. You can analyze each and every example. You can design any number of any networks. Each and everything can be done. with the help of that demo version. So whenever you open the Power Factory, it comes with the preloaded examples. Here you see Power Factory examples. We have application examples, examples from the literature, and example from the standards. In each of the tab, there are some other options available, which includes in the application example. Here we have options of low voltage distribution network, medium voltage distribution network, transmission systems, distance protection, state estimation, industrial network, hydropower plant, wind farm, offshore wind farm, the railway supply system. In each of the tab, you will get one running project. Here, this is one running project. You just click, then this project will start running in the Power Factory. In the same way, you will get some of the video tutorials which will open in the YouTube of the DIgSILENT page. So these are the base models. You will get a description about how to use the base model, how to use the load flow calculation, how to perform the load flow calculation, and quasi dynamic simulation, and the cable reinforcement. These all things you will get in the in the form of YouTube videos. And again, the same way, medium voltage distribution network, you will get one active project. You just click and you start running in the background. And in the same way, some of the tutorials. So in the same transmission system design project, you will get one running project. So the best part of these projects are you can analyze these are writable, means you can also design what according to you can modify according to your need. You can add some other equipments, you can add some other power system elements, you can change, you can act any add any effects devices, you can add any PV system, integrate with other systems, and analyze and compare with the previous one. So these all things can be done. Okay. In the same way, in the example from the literature, we will get 9 bus system, 14 bus system, some of the famous bus system that are used from that is from the copied from the literature. Here you'll get a small description: 9 bus, 14 bus, 39 bus system, 30 node feeder, RBTS bus 2, SSR, HVDC. Here we will get again the one running project, and we will get a small documentation of around 50 to 20 pages, in which you will get the the, the various values of the buses, how to design the 9 bus system, the values of the generator. These all such in whole the data you will for the 9 bus system you will get in this documentation file. And again, and last, from the example from the standard, these are some of the norms related to short circuit analysis, like IEC 60909. Maybe you may be not familiar of these things, but these are some of the norms which are related to some of these are German standard, some of these are American standards, ANSI. These are different way of calculating short circuit analysis. So different way of algorithm they perform to calculate short circuit analysis in the DIgSILENT. So these are those norms. I have a proper documentation of these norms. If you want to read, I will refer to you. And these are some of the norms which are related to short circuit analysis. So again, the same way you will get one running project, and again some of the documentation comparison. These all such things. So these things you will get when you will start the Power Factory as Power Factory examples to better understanding the software. That if you are a beginner and you want nothing how to just draw the networks and these such things, you will just take help from these Power Factory examples. Okay. Now here we see this is gray color, which means right now there is no project is active. So to make any project active or start any project, what we have to do here, option of file, you have to go to file, and there is option of new, click new, and then project. The three other options available: project, derived project, and the combined project. So as you are working on a derived project, means if you're means in the same system there are some other projects and you want to derive, or if you want to combine some other projects you can use. But as we are using as for our own, then we will use the new project. Here what we can do, you can specify our name. Here we see my default name, it is showing the project 123, means right now I'm designing or going to create the project 123. So it takes the number as a default. But if you want to design uh, any particular kind of analysis, like if you're working on a short circuit or load flow or optimal power flow or any kind of analysis, if you want going to perform, you can specify the name here. It will be easy to you, it will be easy for you to search those file. Because when you will search from the library, it will be like project 123, and if you search you will get your name. So better is to give name. So I'm just giving it the default one, that is project 123, but you can give your name. So here we can specify the name of the project, name of the anything you can specify here. Click OK. Here to change nothing, you can specify owner, and this is something that is not mandatory. If you just click OK, if you want to specify, okay, and click OK. So this is the first screen of the DIgSILENT Power Factory. Even you will see after creating the project. Now I will tell you what are the different tabs and what are the different bars here. So first is this main menu bar, which includes various options available to us like file, edit, view, insert, data calculation, output tools, windows, and help. The file include the new that I shown you how to create the new project. Example already shown you how to just see the examples, get an idea about the how the Power Factory works. Activate and deactivate of any project. If your if any project is active, if you want to deactivate and import any other file, then you have to deactivate it. So regarding that, this is activate and deactivate project. Activate any particular study case. There are some of the examples in which in each project there are some of the study cases like with little bit difference. So this is for that, like if you want to activate any study case or deactivate any study case, for that import and export option is also available. Lots of import options are here. .pfd format is of Power Factory file, then DIgSILENT are some of the different files. So import also option is also available. We can also import the, like if we want to just download any PFD file from the internet, like right now I want any modified N bus system, so I search from the net dot PFD file, that is Power Factory file of the any modified N bus system, and then I downloaded it. Then how to just import and export, these all things I will show you later. And then export graphic, like you designed any network, and for the research purpose you calculated and you got all the calculation, and for the research purpose you will be needing that diagram. So this is for that. And then printer, and these all some of the regular stuffs. And in the edit there is not much thing. View, this is freeze mode, which just disables the library. Here we see this is our designing library, the various equipments given in the Power Factory. Now if you just disable this freeze mode will be disabled. Okay, so and then if you add bookmarks, zoom in out, then heat map, these all things are here. Now after the insert, there are some of the insert options. These are in which if you want to insert single line diagram, geographic diagram, the block frame diagram, the plot. If you want to just plot the any kind of curve, this is for that. Data, this is very important. These two options very important for the data manager and network model manager. In the data manager, there are some of the different libraries for designing the controllers like AVRs and governors and SVS. There are some of the lots of models available. First order, second order functions model available for the designing of the controllers. And here, Open Network Model Manager. If we calculated the load flow, and we got all our data from the network, the active and reactive power of the current value, and we just copy all our data and just paste to the MS Excel. So we will be taking help of this Open Network Model Manager. And here some of the other options: study cases, grids, diagram, these all things. This is the main important part that Power Factory can perform, the calculation part. Here we have again that I've already shown you in the slide, but I'm just showing you once again the load flow, and load flow calculation. I already told you that the base package and the advanced package, that is same in the both of the version, that is education version and the research version. Only difference is the number of the bus bars. Okay, so load flow and load flow sensitivity, short circuit, and it is short circuit contingency analysis, contingency definitions, contingency analysis, so contingencies, these all things, quasi dynamic simulations, network reduction, RMS, EMT, the most basic one, and then modal values or eigenvalue analysis, frequency response, system parameter identification, protection functions, arc flash analysis, cable analysis for quality harmonics, transmission network tools, in which you will get PV curve, QV, PDTF, transfer capacity analysis, distribution network tools, you will get tie open point optimization, voltage profile optimization, voltage sag, table assessment, backbone, these all things. So the advanced things. that I'm not aware of these advanced things. Maybe you researchers might be knowing regarding these things. And then probabilistic analysis, this is added in the 18th version. Before the in the 18th the 17th version there was no probabilistic analysis, so added in this year only. And then this is the reliability analysis functions added in 2017 version. So this is the best part of the Power Factory. They add some of the modules, some of the analysis part by developing and researching to the Power Factory. And then optimal power flow, state estimation, techno-economical calculation, motor starting, and the toss automation. These are the whole calculation part that can be performed with the Power Factory. Okay. Now, some other output options, documentation, the device data. These are means how to get the output after the performing the analysis. Some of the tools, text editor, these all things. When you will just download the demo, you can analyze according to your need. This is Windows. If you want to just adjust the layout of this whole window, if we want this projector window to disappear, we can just untick this, and this will disappear. This is dock output window here. This is output window. These all things. So we can just adjust the windows according to our requirement. And then help. This is most important for more learning of the software, because this is very vast software. If you want to explore more and more, you have to you must be using the various references, various scripting references, various technical references, because no one can just make you understand such big softwares in a small period of time. So you have to just work on it. So for that, there are lots of tutorials, start tutorial, and the user manuals, hotkeys, technical references, scripting references, and additional package. So if you start from the user manual, if you have 1200 pages, I will show you. And then technical references, here are the technical references. You will get some of the models, production devices, result variables. In a scripting reference, DIgSILENT has three way of calculating things. One is single line diagram. One is you just pick and drop these things. You just connect with the other equipments, design the network, and then what you will do is just simulate the network. Another thing is DPL, that is the silent programming language. You have to write the codes in the same way you just be doing from the with the MATLAB. So you can do with that one also. And there is a DSL, that is the silent simulation language, means designing of the controllers, designing of the models, and this integrating with your network. So the three options available. So in the scripting reference, you will get the references of DPL and the Python. The programming language is based on Python syntax and C++ syntax. An additional package, here we see the programming interface, API, DGS interface, OPC, DPL. What are these programming and API interface? For the here, right now we are just seeing the GIS industry is moving, just grooming very fast. So if you want to just integrate GIS or SCADA integration to the Power Factory, you must be requiring these two interfaces. So for that, these are some of the documentation, then how to just connect with the help of DGS, data exchange format, and programming interface API with the Power Factory, so that you can just analyze the data that you regarded from the GIS to the Power Factory, and in the same way with the SCADA. So again, the same way, these are some of the different models available to us. So this was in the main menu bar. This is main icon bar, which includes, here we see lots of icons available to us. That's why this is main icon bar. If you want, just this is shortcut of opening data manager. This is shortcut open network model manager, and data assessment shortcut for network load flow, short circuit, edit short circuit. You see the lots of icons. Again, this is change toolbox. Here we see this is the two icon right now, but if you change this to toolbox right now, this is RMS simulation listen. If you change to modal values, this will change, this whole icon will change according to the option you just chosen right now from the change toolbox. So that is, so just leave it this default. And there's some other options of plotting, these all things. So this is main menu bar, main icon bar. This is for the just graphics bar, main graphics bar. In all the things related to graphics, means zoom in, zoom out, and just crop, and these all things. Title block, legend block, introducing coloring, and if you want animated load flow, if all those things lock these all things can be performed with the help of main graphics bar. This is what this is a navigation pane window. Whenever we design the big network, the whole big network can be seen in this small navigation pane, just to analyze and just to get little bit idea that how our network looks like. So this is what that's navigation pane window. And then what this is project window. It tells us about which project is currently active. Like here this is saying grids one active, default one, so this will show as a default. But whenever you create any project, and also if you created some other sub projects which is also called as study cases, so all those study cases will be there here in the project overview window. Then here it is. What is this? This is the output window. It shows for the error, warning, information, event, and some of the other things. So this is the main output window. Now, what is this? This is our designing window. Here we will design our network. So here we see the whole interface is pretty easy. You will just choose your network. If you have a schematic, if you have the data of the various equipments, that what data must be filled with each of the equipment, the connection of the network, the designing of the network is pretty simple. I will show you how to just design the network and fill the data, and then you will analyze then how it is user friendly from the other software that is available. So if we start, then here we have the bus bars, the lots of bus bars, junction terminal nodes, rectangular bus bars, circular bus bars, and the polygonal bus bar. So these are some of the types of bus bar. Now if here we have with the tie breakers, double bus bar system with the tie breakers, 1 by 2 bus bar systems, single bus bar system with tie breaker and the bus bar, lots of bus bar with the tie breakers, and some of the basic bus bars are here. Now here are the sites. Like if you created any network and you want to connect with the other network, just create any site, click on the site. This will open one other page and just design the whole network and then connect the one side to the another. So for that, these are the sites: circular side, rectangular side, substation rectangle, and the secondary substation. Circuit breakers are there, disconnector, load break disconnector, load switches, fuse, and the logical switches, grounding switch, surge arrestor, NEC, NER, some of these things. So generation units, we have external grids, synchronous machine, asynchronous machines, doubly fed induction machines, a static generator, for the renewables, static generator, wind generator, battery storage, fuel cell, and the PV systems. For the voltage source, we have AC voltage source with two terminals. Now AC current source with two terminals, impulse sources. And after that, what we got is general load, medium voltage load, low voltage load, and some of the connection requests, some of the sun filter, RLC, some of the filters, harmonic filters. Here we have static VR system, that is SVS, lines, various types of lines, series reactors, capacitor, then two winding transformer, auto transformer, step voltage regulator, three winding transformer, four winding transformer, the booster transformers for the designing of the effects, and also like models like a STATCOM and TCSC, UPFC. Here we have some of the power electronic equipments, HVDC, rectifier inverter, one DC connection, two DC connection, PWM converter, and DC soft starter. Some of the power electronic equipments, DC machines, relay models, inductive DC walls. This was the whole single line diagram library. There are some of the other libraries we like for the controller designing, like various other uh, first order system, the second order system, various other macros for the like AVR, SVS, all those things. So those are the in the libraries of the DSL. So I've told you about each and every part of the Power Factory, like what are the various tabs and what are the various bars. Power Factory. You must be familiar of all the labs. This main menu bar. This was main uh, icon bar. This main graphics. This projectory window. This is a designing window. This is our library. This is what output window. Now, how to just connect the equipment? I mean, how to just just copy and just how to import the equipments for system equipments from here to designing window. So for that we just click once. Here you see with the cursor there is one small bus bar attached right now which shows that bus bar is currently active. Okay, so as many time you will click on the designing window, the bus bar will be there. So like I want three bus bars. I'm just designing a very general network, so I want three bus bar. So just click three times in the designing window. Okay, so here we see we have three bus bars right now. And how to just deactivate the bus bar, just once right click. Okay, here you see the bus bar disappeared. Now what are the things we can perform with these? We can just enlarge, we can just increase the size. Okay, from here we can zoom. Right now this is on the page level, reduce to like more to 75% for better visibility. Reduce the spaces between them. You just click and drag, click and drag. Now I'm dragging. Okay, now what will I do? I will now connect a line here. So here we see again I've chosen line. So here we see with the cursor a line is attached. Just once on the terminal from which you are starting, just click once and drag till the terminal you want to connect. Okay, connected. See, the connection is very easy. Now choose any transformer. Again connect, connected. Choose any load and just one grid. Just reduce the size so that it can be seen in single page. Okay, so this is our very basic simple networks, consist of around each and every primary equipments of the power system, like buses, the generation unit, the transformer, the line, and the loads. Okay, now what what other things we can perform is how to just edit the data, means how to we can perform. And before just performing any particular kind of analysis, we have to just edit those data. So first you must be thinking that this is what are these things. So these are the cubicles we source for the data. Like if we executed the load flow, it will show for the active power, the current value. And what are these? These are the circuit breakers. So these are the cubicles which will show. Again, this is the cubicle. Okay, now if we start with the bus, what are the options we can just perform with the bus? Options we can change. So for changing, either we double click or right click and edit data. Okay, so this basic data will page will open. There are other some of the sub tabs available, like description, load flow, protection, type, open partition, reliability, optimal power flow. But we have to only fill for the basic data. So here the default is 110 kilovolt. So I'm not just filling any data. I'm just showing you what are the options we have for the bus. So what we can change for the bus, we can change the system type. Okay, AC, DC, AC, and then phase technology we can change. And then the bus bar, what is the usage of the bus bar, that we can change. The line to line value after this is showing after the conversion to line to ground. So these all things we can change for the bus. Now if we start for the 200 transformer, we can introduce number of parallel transformer with thermal rating. I haven't edited these option for real, but I'm just showing you the basic option that I have to edit is edit. Here we have in the type option, you have three options: select global type, project type, and new project type. Okay, first let me show you the new project type. What are the options we can do for the transformer? We have name 200 transformer, and the technology is a three-phase transformer. Okay, so we can change the technology: single wire earth return, single phase, and three-phase transformer. We can introduce a rated power. We can change the nominal frequency. We can change rated voltage, high voltage, and low voltage side. We can also introduce the vector group, that what kind of vector group it is in on the high voltage side, on the low voltage side. So we can do that. And if we have any phase shift, we can also specify any space shift or a phase shift. And then high voltage, low voltage size in values, positive sequence impedance, short circuit voltage, copper losses, zero sequence voltage. These all things are the basic one. Means your work will be sufficed with these much of data. But if you want your result to be more ideal and more clear, there are some of the others data we can also go. Like in the load flow option, you have no load current, no load loss. These are some of the other things we can also edit, but I haven't edited these. I haven't used these data, or I haven't filled these options. So you can change, but I'm just showing you the basic one. In the same way, you will get the description and in the version, and then the load flow. Again, the short circuit, you will get some of the things: short circuit complete, ANSI, IC. What are these? These are some of the norms that are related to short circuit analysis, like VD, IEC, complete, ANSI, RMS, EMT. These all things are for the short circuit. So you can perform these things: high voltage side, low voltage side. These all things we can perform with the transformer. Okay, now already shown you. Now what we have with the line. Okay, here we can change the length of the line that is necessary, derating factor if required. If you have any derating factor, then you can change what is the laying of the ground or air. That can be changed. I haven't seen any value much change after changing these. Line model can be changed, lumped parameter or the distributed parameter. Now already shown you the new block type. Let me show you the global type. What are the global types we have? Global type tells you about the data that are fed in the Power Factory and that are being used all over the globe. So what we have, like open this IEC. Here we have 10 kilovolt, 110 kilovolt, 15 kilovolt, 1 kilovolt, 20, 30, 60, and 60 kilovolt. Okay, just click. I'm just clicking on the any random option. This 15 kilovolt. After that, it asks about which is the material you want. So aluminium and copper, choosing this one. Paper and VP, choose anyone. So these are the data that are given in the global library of the DIgSILENT. Like if you're working on a particular kind of project in which they have properly specified that you have to use this value of data, this much, this must be your uh, metal and these all things. If they have specified, you can search from the global library. If it is available in the global library, then simply what we do is just click and click OK. You get all our data from the global library to your network. Like here we see, I've just clicked OK, and what we got is rated voltage 15 kilovolt, rated current is 0.31. In air, it is. This is not necessary. If you just fill the rated current, I'm just telling you that if you have rated current in ground, that it's okay, and if it rated current in air is also here. Now nominal frequency, what is this type? Cable and overhead. So this is cable. System type is AC. Phase is 3. There is no neutrals. Now these are the parameter per length 1 to sequence in ohm per kilometer. So that is AC resistance at 20 degrees Celsius and reactance. So we will get all our data from the global library just by clicking OK. But the most important thing is this is only read only. Means if you want to just edit these data, that can't be edited. You just click OK, and this will starts in your network. You can't edit any of the data. So this is the global use of the global library. If you just create any new project, there are some other options available, like line type, tower geometry, and the cable definition. Okay, line type already shown you. You will get these options. Now what you will get in the tower type, you will get tower type, name, frequency number, earth file number, line circuits. What is your input mode? Geometrical parameter, electrical parameter, earth conductivity, conductor type. These are the advanced things you can use. But basically, the for the requirement, we only use new project type and this line type. And then again, tower geometry types, some more. Again, here you have to specify number of earth wire, number of line circuits, then earth wire and XY values in the meters, coordinates. And these are the coordinates for the phase circuits. Okay, X1, X2, X3, Y1, Y2, Y3. So you have to specify these things. And then last is cable definition. So this, I haven't used these things. I only use this new project type and the line type. So the most basic one is this. Okay. So number of parallel lines, these all things already shown you. Now what we have at last, our load. Okay. And so in load, what we have in the load flow option, here we see input mode. Here you see in the input mode, here we see various options. If we have data of active power and reactive power, we can choose P and Q. If we data of active power and the power factor, we can choose this. If we have data of the current and power factor, in the same way we have the other options available. So default one is active power, reactive power, and the voltage in PU value. So right now this is in the balanced. If you choose the unbalanced, if you like, if you want to perform the unbalanced load flow, just click on balance. What you have to do is just click active and reactive power for all the three phases. This so we'll do unbalanced one. So this is the options we have for the load. Okay. Okay. So in this way we can design our network. We can just create and we can edit our data. These all things can be done. Now let me show you. One minute. Now if you want to just delete and these all things, that can be done from here. Right click and just click, and from here delete, and this whole network will be deleted. So in this, like from the beginning I told you about all the various types of bars, and now how to just create the network, edit the data, and then how to perform the calculation. Now the very important thing is where to download the demo version and how to download the demo version of the software, so that you can use the demo version software for your better understanding of the software. So DIgSILENT has its own website. You will just go to www.digsilent.de. Okay. The DIgSILENT website, DIgSILENT Power Factory System Software Engineering. This is German software. The head office is Germany. And now from here, I'm just showing you once more. When you open this site, www.digsilent.de, then click here and then Power Factory. Search Power Factory. Oh, okay. So we are using Power Factory. There are some other products, station wire power factory monitor, that is not related to and also not our requirement. So what we are using Power Factory. So what we will do, we have to go to demo request, click on demo request. Okay, and then what we have to do is just fill this small form, and then you will get a demo of the Power Factory that can be used for 28 days. I'm just going to tell you what are the options and how we have to fill form, and what is your requirement of the software. Like this is Power Factory application. If you are interested in these types of uh, what's your application, like if you're working on transmission distribution industry, power, wind power, PV system, smart grids, you can choose. This is just for the collection of the data. By choosing this Power Factory application, there will be no change in the software. This is for just for the collection of the data of the DIgSILENT. So you can just choose Power Factory area of application. Then what is the purpose of use? Here it is. You will not use commercial because as you are using for the research and education. So here are the two options: research and education. So if you download the education version, there is only limitation of the 50 number of bus bars. As Power Factory comes with two variants, already told you before that the education version comes with 50 numbers of the limitation of 50 numbers of bus bars. You can design only up to number 50, 50, and in the research version there is no limitation of the bus bar. Okay, and all those analysis parts and each and everything are same in both Power Factory. So if you just download the education version, you will get a demo in which you can analyze only for the 50 number of bus bars, and in the research you will get for the unlimited number bus bar. After that, you just enter your name here, surname, email address. The first thing is here it is, please ensure that you enter your official company, university, institute email address, which means Gmail, Hotmail, Yahoo. This will not accept Power Factory will not accept these mails. You have to write the email which is specified or which is on your college domain. Means if you are from any company, it must be on your company name, or if you're from the college, this must be from the institute domain name. So from here, after that, you have to fill the email address here, fill the number of your phone number, company names, country, postal code, all things, and then click submit. So it will take around 24 hours to get the Power Factory demo, and after 28 days you will get a proper mail in which there is an option of how to download the software, and there will be a key and how to install the software, and then how to activate the demo version of your software. So so there is a proper description you can download and just use for the better understanding of the software. What are other things we can get from this silent site? The support option. Click on the support option. The support option, here we have examples, webinars, videos, knowledge base, support ticket. These are for the paid users and perfect user. So this is the most important thing that I just want to show you, that is knowledge base. Okay, click on the knowledge base. Okay, so what is this most important thing just want to show you, that is FAQ, that is frequently asked question of the DIgSILENT. So here we'll get our around 325 items related to Power Factory. See, this is our example. This is our one query, that how can I simulate a network with unsymmetrical voltage with different phase impedances. Again, there are some other queries related, and what you will get in the detail option, you will get a description how to use, and also a PFD file, that is Power Factory file. What we can do, we can simply download this Power Factory file. We can open in the Power Factory our software, and we can just import, and then we can analyze such kind of network and such kinds of models. So this is the best thing that I just want to show you, that is Power Factory FAQ section. Now uh, okay, 1 minute. Okay, so this is the our search box. Here we can search the FAQ. What other option, filter options is here. So here the categories and the tags. To make your search more specific, here are the categories and tags are added. So like here we see a data model, dynamic simulation, handling, installation and licensing, interfaces, load flow, work and models, power quality, protection, quasi dynamic simulation, scripting, and the short circuit. So if you want to make your search more specific, we can just simply just choose any of the category, and also to make it more clear, you can add some of the tags. Like if you want short circuit, and you want short circuit in any kind of these tags, we can add some tags. After that, you can just search your FAQ. Like the very basic search, if you want the facts file, we will search the facts. After searching facts, what we will get from the FAQ section, we will have these options. This is one query that give example of facts, that is TCSC model, thyristor control, series capacitor. And here what we'll be getting is, I'm just showing you, Here is attached an example of TCSC thermochronology software, including a control for power oscillation damping (POD) used for the RMS simulation. A simple description and then a Power Factory file. So what we do is simply download it, just install, import it into your Power Factory, and just we can analyze this TCSC model. You can also modify these models according to your need. Okay. In the same way, this one TCSC, UPFC, TCR, and the StatCom. You will get 4 models in the facts. In the same way, again, if you search for the PV system, PV system, do example how to use PV system, how can analyze a microgrid with PV and battery using quasi-dynamic simulation. I'm trying to simulate a so here the enriched library of the FAQ, in which you will get a proper description of what if you have any query. You have to simply search from here. After search, you will get uh, this examples, and then you can also have some models also you can download. So this is the 2 things that to show you. Now what we have, we can ask from the demo from here. First we'll go to DIgSILENT site, and then what, click on this icon and then ask for the demo. Just fill a small form and then you will get a demo request. Okay, so this is a way of getting the demo, and this is a way of use how to use the FAQ section. These are 2 things that to tell you. Okay, now what are the things, references for the better understanding of software, better learning software are available to us. So these are, go to help. Okay, in the help there are tutorials, start tutorial, user menus, and the hotkeys. Okay, now what if you start from the tutorial, here you see tutorial of 101 pages. So what we the data we have, introduction of the tutorial, how to use tutorial manager, troubleshooting, these all things, documentation, creating a tutorial project, creating power system element, data manager, these all things you will get in the tutorial one. So tutorial of 101 pages. So for the basic how to just start the Power Factory, how to just create the power system element, how to connect the element, these all such things you will get in the tutorial. And then in the help, again, this is the most important thing, that is user manual. The user manual is of around 1200 pages, and here you will get each and everything. Your all your query will be here. Okay, here you see the 1211 pages. So here what we'll get is general information about this guide, is all things how to use this guide, and then administration of the Power Factory, user account is all things, then handling, how to use the handle of the, you can handle the power system, and then power system analysis function. Here we see all those analysis part that I was showing you before. You will get a proper description about all these things like load flow, short circuits, contingency. Like if we just want to learn how to use the load flow in the Power Factory, to just click load flow, minimize this, zoom to level of 100%, and just start reading. So first there will be theoretical description that what load flows does, what is load flow, these all things, what is the practical requirement of the load flow. So we'll get proper description, and why the engineers, why the network designers use load flow for the designing. So this is proper description about the load flow, theoretical description, and then related to Power Factory. Okay, so this is, in this way you will get whole description about various types of options available to you. So this is some one other thing, that is user manual. What other things, like here we have technical referential, click on the models. That in the models you will get the all those equipment that is available in the library, like branch element, transformers, load flow controllers, sources, measurement devices, digital devices. You just click and you will get a description how these source and how these equipments can be connected with each other, and what are their values, implementation. These all things, all those data can be used from here. And then scripting reference you will get it for the DPL and Python that I was telling you before. Click on the DPL. Okay, so you will see again the DPL is scripting is of 700 pages. So you will get a proper how to use the DIgSILENT programming language. Okay, so this is one other reference. Now, what are additional package? These are some of the advanced things that you might not in requirement of. So I'm just leaving those. And then what's new, you will get a one more PDF of what's new and release notes. So these were all for the help, like, and after just if you just purchase a software, you will also get a 1 year support from the DIgSILENT Germany, in which you can just create your request, create your query, that is called as support ticket. So you can also support a ticket, you can just ask your query from them and they will reply back. So there is a lot of support available from the Power Factory. You can search from here, you can search from the user manual, you can ask the queries, you have the FAQ session, and also us supporting you. So these were all about how to use and these all things. Now what we will do is, let's create a small network and just fill the data and just analyze the various things. Okay, now load flow analysis. So what does load flow does? It just gives us the value of active power, and the current value. So what are the load flow analysis environment here in the Power Factory? So it can be for done for the balance and balanced load flow, for the coupled AC and DC, any type of grid. As you see, shunt and tap controllers, station network controllers features, local remote controller option, lots of controller options here in the Power Factory. And then automated feeder load scaling. These all things related to controller design are with the load flow. We can analyze such things. And what is the load flow environment? Load flow analysis environment is based on Newton AC Newton option technique, that it can be used for both balanced and unbalanced, which is extremely fast and robust for active power flows. And another one is the DC load flow, and it can be applied to any combination of 1, 2, and 3 phase AC/DC system, HV transmission system, and then to down to residential level, and then to use industrial level also, and at the lower voltage levels. High volt HVDC system, fax devices, all such things can be implemented and can be performed. Now in the short circuit analysis, the short circuit calculates for the fault level. It gives us about the various current values, peak, short circuit time, such various types of values. Here we see the network, it shows for some of the values. And you can short circuit can be performed for the whole buses, and on the, if you want on the selection basis, you can also select any particular line, a particular bus, and you can simply create a short circuit. Okay, now what this base package of the short circuit that I was talking you before regarding those, these are support of IEC 60909, IEC 141, ANSI, VD. These all such things are some of the norms related to short circuit. And calculation short circuit in DC grids according to this one, ANSI. The most important model is complete supermotion method, which includes dynamic voltage supports of generator connected via power electronics, and then multiple fault load analysis. And what is then reporting options are, what are the reporting options, and how we can just analyze the with the help of the graphs. So here we have display of any variables with single line graphics, station diagram, and the flexible data page. Full flexible filter mechanism to display objects in color mode. We can have the heat maps, and we can just generate a heat map in which we can get a little bit idea about what like what are the levels of the different parts of the network. Like if you have certain level more than any particular range of pu values, it will show a red color. If we have means in the permissible limit, it will show the green level. So we can get a little bit idea about the network. Okay, detail analysis reporting, which can show you overloaded items, unacceptable bus voltage, system islands. These all things can be done. Detailed text output with predefined user defined filters and level DeepL interactivity, and all those results that we got can be imported to the other software like MS Excel. So these are the options we have for the reporting. Okay, now if we start our network and just create a small network, and then let's see what are the options and how we can execute those. So first thing, let me start with the buses. So choose this bus. So what I'm designing, choosing would be 5 buses: 1, 2, 3, 4, and 5. Okay. Now why I'm just chosen 5 buses in the horizontal manner, because in you can design your network in this way. Like vertical means you can connect 1 bus, 2 bus, 3 bus, 4 bus in the vertical manner, and also can be connected horizontally. So for connection, connecting horizontally, what you do is we also rotate it to the clockwise. Okay, so and then what we have to do is just connect grid here, connected 2 lines. Okay, 1 transformer, again 1 line, then one more transformer, and then we will connect the loads. See, designing was very simple. It really took me around 30 to 40 seconds for designing 5 buses system connecting with these type of equipments. In the same way, like I chosen for the 5 bus, you can design for any number of system. For the 9 bus, 14 bus, it will also nearly take around 5 to 7 minutes. Okay, now what we will do is start editing the elements, starting from this terminal. Go to basic data, change this level to a level of 1 minute 33. Okay, click OK. I'm first just entering the value of all the buses. Now this is bus 2. Here we see there is no transformer, so this will be also 33. Here this is a 200 transformer, and I'm considering this as step down transformer. So this I'm stepping down to a level of 11. Again this would be at 11. This bus would be at 11. This is also a step down transformer. I will edit these data later for the transformers, and this is at point 4. Click OK. Now these are the edited the values. Now we'll start with the line. And the line is 10.12. Editing factor is okay. Go to type, new project type, line type. Rate voltage would be 33. It is connected to 33. The rated current in ground is 0.4241. 50 okay. Cable is okay. AC leave it AC resistance is 3454, and this is 9234. Here we see this is ohm per kilometer, so that's why the value is a little bit too much less. 3454 334241. Click OK. Okay. Same data for this one also. 10.12. Rated voltage 33.4241. Now 3454 and 9234. Okay, 9234. Okay, now this line, length of the line is 2.67. Go to type, line type. Rated voltage would be 11 at that is connected to that 11 kilovolt bus. Rated current is 1234. Resistance is 1204. Reactance is 2304. And just click OK. Now we start for the transformer connected. Go to type. This is a level of 150 MVA. Normal frequency is okay. This will be step down from a level of 33 to 11. Short circuit voltage is here that I have is 10%. Copper loss is 10.5 kilowatts, and leave these data as default value. Click OK. Click OK. Now this transformer, this is at 50. Voltage is 11 to 0.4. Short circuit voltage percentage is 6%, and copper losses 7.5 kilowatts. Okay, now we start with this load one. Load flow default. Right now the data that I have for this example is for the active power factor. Okay, so what we will choose is P cos phi. Because why? Because data that I have is of active power and power factor. Active power that I have is value is 0.78. 1 minute. Active power is 0.78. Power factor is 0.96, and PU voltage set point is 0.9534. 0.79, because 5. Now this load also active power is 0.65. Reactive power is no go to P cos phi, and power factor is 0.95, and voltage set point is 0.9565. Okay, at last P cos phi active power 0.45, power factor is 0.92, and voltage is 9123. we started from okay, one more. Just give this PV okay and give active power to 2 megawatts. Okay, so what we started from the terminals. This network is like 33 kilovolt. This is at 30 kilovolt bus. There is no transformer, so this is also 33 kilovolts. This step down transform is stepped down to a level of 33 to 11. Again, there is a line and then load. Again, this bus, so this also has 11. Then again, one transformer which is stepping down to from a level of 11 to 400 volts. And then there are three loads and a grid, external grid. So what we'll do, you go to calculation and then perform the load flow. Okay, now what are the options we have for the perform of the load flow? Here the calculation methods are AC load flow balanced positive sequence, AC load flow unbalanced three phase, no DC load flow, that is linear one. So the advanced option that we have, we can active power regulation, automatic tap adjustment of the phase shifter, automatic active power limits. If you have knowledge of regarding these options, because I don't have and haven't used these options. So you can also for the voltage or reactive power regulation, we can tap adjustment of the transformer, tap adjustment of the surge. These all things can take. You can consider these options, and then what we have is active power control as dispatch as one is secondary control according from me. These options, all those options that are related to control, you will get all a proper documentation. What are the difference between if we choose the control as dispatch and what are, if we choose to the secondary control, we get all the options in the documentation or in the user manual that I shown you. So you can from there you can get a little bit idea about how the Power Factory values and how this control can be changed if we change these active power control options from the dispatch to inertia to the primary control to secondary control. These things can be done. And then again some other things like related to by reference machine, by loaded reference bus, by static generator reference bus, distributor slack by loads. So this is related to balancing. So again, just saying, if you just want to learn these things, where is some of the advanced options, you can just simply refer to the user manual that is given with the Power Factory in the help option. And operational limit simulation advanced, leave it. The calculation setting, that is load flow method, is based on Newton technique, that is related to current equation, and the other one is Newton power equation. And output is all such things are given in the. But what we will do, we'll go with the basic one, that is AC load flow balance positive sequence. Why we are choosing the balanced one? Because all our loads are balanced, shown you. Then if your load is unbalanced, what you do is you simply just click and fill the data of active and reactive power for all the three phases separately. But as we just edited only two values, that is active power and the power factor, so that's why we are performing the AC load flow in positive sequence. And just click execute. Okay, here we see the green color load flow executed. Make it zoom. What we are getting here, we are getting the active and reactive power of the current value. Okay, okay, see. Okay, now our load flow executed. What are the other things we can perform? Okay, so what are the options we can perform with the after execution of the load flow is the heat map. Here it is, the heat map of the network. Calculate here it asks for the low, medium, high resolution. These all such things it asks. So simply execute this. Okay, here we see there's not much difference in the, all are in the green colors we source, all are in the permissible voltage level. There is not much any load or something. Yes, why it will be, there is, as there is no control, there is no generators attached. This is a very basic network which includes some of the uh, just not too much overloaded. That's why it is showing the only green one. So what does this heat map signifies? So this is very important thing. So there it is, title legend block, introduce this one. and go downward. Here it is. If it is have the low voltage range in PU, means around 1 PU, it will show the green color. Teal color you can see if you have a range of 0.95 PU as such, and 0.9 PU will get if you are getting the blue color. Okay, after that, for the upper voltage range, you will get if you have the voltage range of 1.05 PU and more, you will get the yellow, and more you will get a red. And if you have such voltage range from 80 to 100%, you will get such variation in the heat map of the network. So that's why heat map is very important thing, just to signify, just this will tell you then how your network is behaving, where you are getting too much overloaded, you are getting the more voltage range and more loading range. So you can just rectify and you can make some change. So this is, that's why for a quick understanding about your network, you can use this heat map option that we have. Okay, and then what other things we can perform is here it is, layers option. Click on the layers. Okay, click on the layers. Here it is. We are seeing that right now the direction arrows are invisible. So for making them visible, what we will do, we will just click and just transfer from invisible to visible. So just click here. Here you see the directional arrows move to the visible side. After that, just click OK, and then after layers, move to this one, just to the setting option, and then click to the advanced one. Here we have animated load flow. Click here and execute, and then one more time execute this. So this is the animated load flow, which will tell you a little bit idea how the power is flowing from one bus to another bus. As this is not much needed and much useful for this network, because that network has no branches. This is just a horizontal network. So this might be not that much useful for this one, but can be used for if you have the big network and uh, of 14 and 39 and more bus system. So this is very useful to get a little bit idea on how power is flowing on which bus to which bus. So that's why this animated load flow, for a quick understanding about your load flow. Now,
How we are getting the sensor?
okay, so this is animated load flow. Now if after execution of the load flow, we got well, this much of data, that active power of the current value. Okay, but our requirement doesn't get suffice with this much of data. If we want some more data, like some other internal angles, some other things, so what we can do, we can also change. We can,
Can you repeat the animated, sir?
okay, 1 minute. You have to go to this one, like this was direction arrows before invisible. You make it visible from here. Right now in the it comes in the visible box.
Okay.
Click OK, and then go to advanced option. Here,
Okay.
here we have in the setting option, last tab is advanced one. Tick animated load flow and click OK,
Okay.
and one more time just execute the load flow. So this will start giving the animated load flow.
Thank you, sir.
Okay, and so okay, now if you want some more data, like here it is showing just 3 data, that is active and reactive power and the current value. But if you want some more, what we can do is you can select this, and then here option of edit format for edge elements. Click here. Here in this box, these are the 3 selected variables, that is active, reactive power and current magnitude. Go here and insert row. There's one row got inserted which is blank. Just double click, and then this variable selection page will open. Okay, in the variable selection page, there are the different variable sets, which are current, voltage and power, bus results, signals, calculation parameter, element parameter, and the reference parameter. So in the current, voltage, power, just choosing from the random values, not and that is 1 minute. Positive sequence voltage angle, and total apparent power. I'm just choosing some of the values, and current imaginary part, if it have um, angle between voltage and current, these all things. I'm just choosing four variables. Three were default. So see, I'm just choosing four one. Now we have certain variables. The number is 7. Just click OK. Okay. So now here we can see some other more data after execution of, as when the load flow happens, it is not like it just gives only three outputs. It is based on certain algorithm, so it will take help of some other data also. That's why these all data are running in the background. These all data available to us. So if you have a requirement of those data, we can search from there. Again, just go there, and for deleting, just delete. Okay, now we are just left with the three basic one, that is active hour, and the current value. Okay, now what are the things we have here? This is output calculation analysis. This will show you the whole system report. Let's zoom you, and then just open this. Here we have the load flow simulation, bus bars, tunnels, total system summary, grid summary, complete system report, edge elements, relays, as I haven't connected any relay, so leave it, and control conditions. So what we will do, we will select the complete system report, and in the complete system report, here it is four kinds of report it is asking for. That is for the substation, for the voltage levels, for the voltage level and grid interchange, and the all. So click on all and execute this. So you must be wondering that where this whole output report comes. So it comes here, that is in the output window. So here we have the whole system report. It's a very small network. So if you have more big network, and you want it for the analyzing your and for the comparing, so this report is might be very useful for you. So here we will get a proper description, date, and these all such things. Any controller, these all conditions, what are the options that is selected for the execution of the load flow. And from here, what we will get rated voltage, bus voltage value, active power, reactive power, current, loading, and some of the additional data if you performed the short circuit, is all such things. And then again, a pictorial representation of the voltage, and these all things you will get. Power interchange, total loss of these all things you get in this report. So you can also just download this report in the notepad format. So that is one thing. Just clear all. Okay, now if we just want, like if we executed our data and just we want just all our data to the MS Excel, what we will do, we will go to the data manager that I was showing you before. Now open this network model manager. Okay, so the network model manager, what we have is bus bar. Here we what our network has 5 bus bar, that's why it is showing 5. Okay, uh, in chicken. Okay, and 5 terminals. One minute, I'm not getting this option. There are options here, flexible source characteristic. Mm, officer. Okay, now, okay, so I was actually needing these options, and okay, so here we're seeing this is our 5 terminals. That is, terminals is simply buses, and here we're getting values. Now, if we want, just go to flexible data and go to variable selection, and we just choose some more data and click OK. So we have now 5 data. Now, if you want, just copy all our data to MS Excel. What you do is just select all data and click, and then spreadsheet, copy with column headers, and open MS Excel. So okay, now simply just paste here. Okay, so in this way we can just copy all our data from these, if we analyze or any kind of analysis, and then copy to MS Excel, because as we know, the MS Excel is better in terms of plotting the graphs and the plots. So for better understanding, we can use this MS Excel. Okay, so now if you want, just this is how just we calculated the load flow and all such things. We just know how just want to get the heat map of the network, how we get the load flow, animated load flow of the network. If we want our data from the to the MS Excel, that we learned, and then how to get the data from the background, that we also learned. Now, if you want to execute short circuit and all such things, and if you want the graph related all such things, we can also perform. Okay, okay, so related to load flow, what we have learned, we learned how to just execute, how to just design the network and just execute the load flow, how to just run the heat map, how to get our animated load flow, and animated load flow, and how to get all our data to be copied from the Power Factory to the MS Excel, and all such things can be done with the help of the Power Factory and in the load flow options. Now, if you want to perform or if you want any graph, all such things, then how we can do that? So, plotting related things are here. What we have to do is, here it is in the option of insert. There is a plot option. Click on the plot. Here, see, these are the plots available. Like in the all option, you will get all plots, but here are the filters available to us. Like if you want to perform simulation RMS MT, we have option of binary bar plot, curve plot, curve plot, 2 axis, curve plot, multi-axis, and vector plot. Quasi dynamic simulation, we will get such things. For the modal eigenvalues, we will get eigenvalues plot, mode bar plot, mode phasor plot. For the power quality and harmonic analysis, harmonic distortion waveform plot, probabilistic analysis, protection AC arc flash analysis, they will get such things. Phase comparison, RX plot, short circuit sweep plot, time distance plot, time over current plot, and a general plot you will get bar plot, binary bar plot, curve plot, virtual instrument. These are some of the instruments that we have: digital displays, horizontal scale measurement instrument, vertical scale, and some of the others option like network graphic, picture, schematic path, text. So these are for the making this graph to look more understandable. These are the some others option attached to us. So what we'll do is simply choose this simulation RMS CMT and this curve plot and click OK and click OK. So this is our blank plot. What we do if we just want to plot any kind of variable, what we do first, we will start with the mentioning of the equipment. Like if you want to line loading, here we see this is fixed to 50%. So what we'll do is select and then right click the option of define. Okay, in the define option there are the result for RMS and EMT simulation. So go with this one, result for RMS EMT simulation, and here we have line 2. Double click here. Okay, and in the current voltage power you will not get the loading one. You will in the calculation parameter you will get the loading option. Search loading from here and just tick and click OK. And for the better understanding, just choose one more, like this one also. Define voltage magnitude in PU. Already selected voltage magnitude. Okay. I'm just for the quick understanding, I'm just using two of the variables and how to just plot the graph. So I've chosen the one bus and the one line. The line variable is loading and bus variable is the voltage in PU value. Now just close this. So this was first word was how to defining the equipment and selection of the variables. The other option, what next thing what you do is you have to go to curve plot, double click here, this box will open. Okay, after mentioning and choosing the variable from the variable selection page, we have to move to this curve plot. Okay, double click here and this page, this box will open, in which what we will do, we will again double click and select all calculation. Okay, then go to element. See, we have already defined those two elements, so right now we are seeing just only two elements. Choose line is selected, choose line, and then again what we have to select is line was variable was loading. Click OK. From here we can also specify the different colors of the graph. Lots of colors are here. We can choose, we can choose lots of style of the patterns of the lines while plotting the graph are here. Width also things can be changed, and then again insert row, all calculation, element is terminal, that is bus, and this is voltage magnitude. Okay, so this was one thing, that is y-axis, and in the x-axis not much. Now we can go and change the x-axis variable, that is time second. And we can also edit some of the things like limits, maximum, these all things, but it is not necessary. The advanced option, okay, leave it. In this advanced one, what we have, we can get our curves as bars or draw steps. So right now bars is curves is okay. So we did for x-axis, which selected for the y x-axis and y-axis. Now we have to do is click OK. So here see, before it was blank, now we have, it is showing two terminals, that one is green, another one is loading. Now go to load flow calculation, again execute load flow, and then here we have options available. What are the simulation methods you want to perform? So here we have RMS, that is electromechanical transients, and the instantaneous value, that is electromagnetic transients. How is your network? That is the balance and positive sequence. Yes, our network is balance and positive sequence, so we will choose this one. We can also introduce the step size, synchronize, we can solar option. These are some of the things we can use. So simply go with the RMS one and execute this. Okay, now just edit some, just reduce some seconds and execute, and X, that just the network. Okay, so what are these options available while plotting? These arranges plots on top of each other. Like if you want to compare the two plots, this will arrange the plot, arrange plot automatically. This is for the scale of x-axis, so this is for the scale of y-axis automatically, zoom x-axis, zoom y-axis, and then move axis scale, and then stretch compress scale. So these are all this for the plot. Here we see this is very pretty state plot, because there is no control, there is no short circuit happened. So that's why the value of the RMS value is pretty constant. So but if we plot, if we design with the help of, and we just create a short circuit, and for the 9-bus system also, so the plots will be lots of ups and downs. So that's why this is a way of how to just plot the network. Okay, now just moved over to slide. Okay, so there are some of the other slides we have for the renewables, PV system, wind energy system, hydrogen system. These all things we will do later in the next section. So for today, if you have any query, regarding how to just install this the software, and how was the first experience regarding the Power Factory, if you have any query, you can ask from there is a chat box. From chat box, you can ask if you have any query regarding software.
Excuse me, sir.
Yes.
Sir, how can you get this information, sir? So just now you were telling me about the video lecture just like that, sir. How can you get that information?
What kind of information you are asking?
Yeah, just now you describing how to construct the diagram and how to run that one like that, sir.
That's why I'm showing that. Yeah, I told you how to just install the demo version. You just saw how to just request a demo. You saw.
Okay. So in that one, so in that one we can get that entire
Yes,
this one, sir.
when you will just ask for the demo, you will get a demo, and demo will be valid for 28 days. In the demo request, in the demo of the software, like 1 minute, when you will install the demo, you will be getting same layout like this. So in this, you will get help tutorial, start tutorial, user manual, technical referential, these all such things in the
Okay.
help option. So from there, you can simply download your PDF.
Okay, sir.
Okay.
Sir, one more
Yes.
doubt, sir.
Yes.
Is it what are the advantages as compared with the MATLAB, sir?
So the most important thing is, for the MATLAB, you must be using MATLAB. You have seen with the MATLAB, you have to just draw lots of script. You have to just write lots of script, and then you will execute, and you will get your result. But here, what we have to just like I took around 20-30 seconds for designing such networks. In the same way, for the 9-bus system, for the 14-bus system, for the 13-bus system, it will take hardly around 5 to 10 minutes for the designing, and then it will take around 10 to 20 minutes for the filling of the data, or the changing of the properties of the various equipments. And then after that, simply click on the execute button. Like in the calculation option, these all options, load flow, short circuit, contingency, quasi dynamic simulation, RMS CMT, all things can be performed with a just once. You have to just click once, and then all will you will get the result. So if you see, both in the user friendly environment, the Power Factory is too much user friendly in comparison to the MATLAB.
So by using this TH analysis also we can follow that one, sir.
What analysis?
TH, total harmonic analysis.
Yes,
Distortion.
total harmony can be performed. Here we have, but see one
Fast
total.
Fourier analysis.
Yes, fast Fourier transform, and that can be performed, and the Prony analysis, that can also be performed. So there are some other sessions after that. In
Okay,
those
okay.
sessions, I will show those things.
Okay, okay. Thank you, sir.
Okay. Uh, देखता हूँ. Sir, regarding MI power, I don't have any knowledge, because MI power, if we compare the MI power is India-based software, and this DIgSILENT is German based, and DIgSILENT is used word, means whole word is using DIgSILENT. So if we compare, uh, No, sir. Load flow methods only based on that Newton-Raphson technique. Sir, regarding pricing, I will mail you, sir. Any other query? Ma'am, yes, ma'am. Soumya, ma'am, you asked regarding the MATLAB. So yes, ma'am, you can purchase and you can use. Ma'am, first thing is I've shown you how to just install the demo. So first, go and request a demo. After a demo, you can analyze that whether it is useful for you or not, and then ask for the that you want to purchase or not. So first, see the demo. Demo is valid for 28 days. So use it and then analyze that it is good for you or not. Yes, ma'am. I will send you the this PPT. Ma'am, what template you are asking? कहाँ है यार? Yes, so ma'am. What kind of template you are asking?
So you are telling about this demo, no, sir.
Yes, ma'am.
For that, you can able to give a step-by-step procedure through mail, no, sir.
What kind of how to download the demo? That procedure.
Not demo, sir. You included that values, no, sir, for bus and all.
Okay, ma'am. First thing, you just install the software, and then in this next session, we will do the hands-on practice. Okay, in the hands-on, I will tell you
Oh, oh,
all the data, ma'am. This was just introductory section in which I will be describing about some of the details and what are the options of the Power Factory and how is what is the capabilities of the software. So first, ma'am, you just install this demo, and demo will be valid for 28 days, and then use your and then analyze, and then in the last session, we will do the hands-on.
okay, sir. Thank
Okay,
you,
ma'am.
sir.
Okay.
Thank you, sir.
Okay.
Is
Thank you,
there
ma'am.
any disadvantages come?
Disadvantage. Why there is will be any disadvantage of the software? If you can simply check the Google the capabilities of the DIgSILENT. There is lots of research paper. Let me show you. Uh,
Okay, sir.
mm, and lots of research paper has been published.
Yes, sir.
MC low frequency oscillation of hydroelectric plant. These all are based on the DIgSILENT Power Factory.
Yes, sir.
Yes, madam. So
Okay, sir.
whole world is using this silent Power Factory. So you can simply you must be having the ID of the IEEE. That is what. So you can search that what are the research papers and how kind of research paper are published with the help of the silent Power Factory. You can search from there, and then you can better and just get an idea then how this is how capable is this software. And the best thing is first download the demo, and then you can use.
Okay, sir. Thank
Okay.
you, sir.
Thank you, ma'am.
Thank you, sir.
If any other query, then you can ask. Otherwise, I'm
No,
ending today's session.
no, sir. You can end it.
Okay. Thank you, ma'am.
Thank you, sir.
बंद कहाँ से होता है भाई? Okay.